Jai Hind everyone. I, Dr. Prashant Tripathi, Assistant Professor in Electronics and Communication Engineering Department at Ajay Kumar Garg Engineering College, Ghaziabad, going to present a lecture on WiMAX technology. This lecture is aimed for the BTech undergraduate student who are studying wireless and mobile communication subject. In this topic, we basically cover wireless network, wireless metropolitan area networks, and WiMAX. So, in this presentation, we widely discuss about WiMAX technology, which is a popular wireless access services which we are frequently using in our day-to-day life. When we talk about wireless network, we basically deal with a kind of network in which we are providing the access via wireless. In this network, we are using various services with the help of wireless technologies. The wireless networks are classified as wireless metropolitan area networks. Example is WiMAX, which is also based on IEEE 802.16. It is similar to cellular network, and traditionally it is more similar to base station infrastructure system. Next classification of wireless network is wireless personal area networks, for example Bluetooth, which is based on the IEEE 802.15 standard. The Bluetooth has limitations like very low range, and wireless connection to printer, etc. are the applications of Bluetooth technologies. Also, we can use Bluetooth technology in our mobile devices for transferring very small data. Next is wireless local area network, for example, Wi-Fi, which is popularly known as wireless fidelity, and it is based on IEEE 802.11 standard protocol. It uses infrastructure as well as ad hoc network, which is possible, and its application is home office networking. Today we are using Wi-Fi networks in our premises as well as small offices. Even in our institute also, we are using Wi-Fi connectivity to provide seamless connectivity to our student and faculties and which are residing in the campus. Next wireless network example is multi-hop ad hoc network. In multi-hop ad hoc network, there is no dedicated infrastructure. The connections are formed as per requirement with the available devices, and its uses is military applications and emergencies. It also used where there is impractical to provide a dedicated connections. In this diagram, we have shown the coverage as well as classification of these wireless network. For example, WiMAX technology has a wide area coverage, and it is also used in metropolitan area networks. Wi-Fi is used for local area network, and Bluetooth, which is popularly known as 802.15, used in personal area networks. So, it is clear from this diagram that WiMAX has a wider coverage as compared to Wi-Fi and Bluetooth technologies. All these technologies are wireless technologies. Here, a metropolitan area network is shown in this figure, where every device is connected with each other via wireless. We have plotted a base station, and these base stations communicate with each other, core network, and here we have installed a repeater to enhance the signal strength for long distance communication. and these base stations are also connected the residential customer via some kind of antennas. So this is the basic idea of wireless metropolitan area network. Now we will discuss about our main topic, that is WiMAX technology. So we will see that what is WiMAX technology, how it can be used, what are the basic component of WiMAX technology. All these things will be discussed in this presentation. So first of all, WiMAX is a wireless broadband access technology which is based on Internet protocol, and its performance is similar to Wi-Fi network by the coverage and quality of services of cellular networks. WiMAX basically stands for Worldwide Interoperability for Microwave Access. A wireless digital communication system like WiMAX is also known as IEEE 802.16, and it was designed to implement wireless technologies in metropolitan area networks. The main part of WiMAX technology are WiMAX tower and WiMAX receiver. WiMAX tower is very much similar to a cell phone tower, and it provides a signal coverage of a very large area like 3000 square miles. So, WiMAX tower has a larger coverage area as compared to Wi-Fi and Bluetooth. In a WiMAX receiver, basically a antenna and a receiver, sometime both are inbuilt together, sometime it may be different, is used, and it is usually mounted on the roof to provide the connection with the WiMAX tower. In a WiMAX receiver, the antenna and receiver could be a teeny box that can be built into a laptop like the Wi-Fi access at present. Different standards which are used in WiMAX technologies are basically 802.16. This standard was implemented in 2001, and this was the first version of IEEE standard. The next version is 802.16a to 802.16c. After the implementation of 802.16 2001, the different other versions like 802.16a, 802.16c are approved by the authorities to provide the better connectivity through WiMAX technologies. In 2004, another standard which is known as 802.16 is also approved in June 2004, which provides better outcomes over 802.16a and 802.16c. Next, in 2005, another technology 802.16205 was approved, and it includes mobility also as compared to previous standard. So these are the some basic standards of WiMAX technology, and gradually these standards provides various other advantages over their preceding one. Now we have compared the previous standard with the modern one, and we can see that gradually we are enhancing the capability of WiMAX technologies in terms of its range, data rate, and other factors like 802.16 has a spectrum of 10 to 66 gigahertz, while the spectrum range of 802.16D has a range of 2 to 11 gigahertz, and in 802.16e a range of 2 to 6 gigahertz are used. Propagation channel condition, when we talk about propagation channel condition, in this condition the modern 802.16e standard also includes vacuolar movement motion as compared to 802.16 introduced in 2001, which was only line of sight technology. In terms of bit rate, the 802.16e supports a data rate of up to 15 Mbps, and the 802.16 uh, supports 134 Mbps data rate. In terms of modulation, the 802.16e uses OFDM, QPSK, 16 QAM, 64 QAM, and 256 QAM modulation scheme, while in 802.16 we are using QPSK, 16 QAM, and 64 QAM. In terms of mobility, the 802.16 standard has a provision to support mobility, where 802.16 supports fixed communication. So, in this term, we can compare the different standards which are used in WiMAX technologies. When we talk about WiMAX architecture, the basic architecture of WiMAX is shown in this figure. In this figure, there is multiple subscriber stations which are represented by SS, and BS is the base station which provide connections to subscriber stations, and further the base station is connected with the internet, and this internet also connected with different network management system. So this is the basic architecture of WiMAX technology. The subscriber stations contains three part: physical layer and MAC layer, and these are the managed node which through which the subscriber station communicate with the base station. Similarly, base station also has two basic layer: physical MAC layer, which provide interface to the different subscriber station with base station. The base station is connected with internet, and internet is also connected with various databases, and it provide connections to whole world. Now, when we talk about remote station or mobile station, so these are the user operators like mobile phone that may be placed within the location of consumer. Second is access service network. The access service network in the region of WiMAX network and form the radio access network on the border. This network include one or several gateways and base stations. Connectivity service network. The connectivity service network is one of the main element of WiMAX network that provide internet protocol connectivity and allow the functions of internet protocol core network. Next is subscriber station or mobile station. The subscriber station is frequently known as customer premises equipment, which uses different forms like indoor customer premises equipment, otherwise outdoor customer premises equipment. The indoor customer premises equipment can be placed by the operator. These are frequently available in a dongle form, which is used for a laptop and different applications. The outdoor customer premises equipment provide good performance. Base station. For the WiMAX network, the base station, also known as BS, an important element which provide air interface for the mobile stations and subscriber. The base station is responsible for extra functionality of micro-mobility management functions like the establishment of the tunnel, handoff triggering, policy enforcement for quality of services, radio resource management, classifications of traffic, dynamic host control protocol proxy, multicast group management, session management, and key management. The base station also manages very important functions like handoff operation, provides quality of services, and different kind of power profile management also. Next is access service network gateway. In WiMAX network architecture, the access service network gateway normally work like a layer 2 traffic aggregation point in the overall network. This network provides extra functions like paging, intra-ASN location management, admission control, radio resource management, encryption key, and caching of subscriber profile. This network may also comprise the mobility tunnel management through base station, the establishment of authorization, authentication, client functionality, policy enforcement, quality of services, routing of the selected CSN, and functionality of foreign agent for mobile IP. So ASN gateway is also an important part of WiMAX technologies. Home agent in ASN, we are talking about home agent, AAA, and foreign agent. So first we will see about the home agent. So home agent can be placed in the connectivity service network. A key element in WiMAX technology can be formed with mobile IP, and the home agent works within conjunction through a foreign agent like ASN gateway for giving a proficient back-to-back mobile IP solution. For subscriber, the home agent serves to provide secure roaming through quality of services capability. Similarly, the AAA, which stands for Authentication, Authorization, and Accounting Server, is used to authenticate, authorized, and for various accounting purpose which the subscriber has subscribed. This is included in the Connectivity Service Network or CSN. Now, we will compare the two technologies which we are using widely, and these two technologies are Wi-Fi and WiMAX technology. So, in terms of range, the Wi-Fi uses wide frequency channel up to 20 MHz, where the channel bandwidth chosen by the WiMAX operator ranges from 1.5 MHz to 20 MHz. In Wi-Fi, MAC layer is designed to support 10 of user, while in WiMAX, MAC designed to support 1000 of users. In Wi-Fi is based on connections, no guarantee for quality of services, while centrally enforced quality of services are provided in WiMAX technology. Currently, no guarantee latency for voice and video, but WiMAX is designed to support voice and video from ground up. WiMAX Wi-Fi technology does not allow the differentiated level of service on a per user basis, but in WiMAX technology differentiate service level, for example, best effort for residential and T1 for business customer. It is WiMAX technology is optimized for a range of up to 50 km, but Wi-Fi is optimized for 50 plus meter. In Wi-Fi technology, there is no compensation for near and far, but in WiMAX, it is designed to handle many users spread over kilometer. In Wi-Fi technology, no mesh topology support within ratified standard, but it WiMAX technology support mesh network topology and advanced antenna techniques. Basically, when we talk about WiMAX technology, so the standard for WiMAX technology is 802.16 and it provides a broadband wireless access and it provides higher bandwidth over long range transmission. It uses two air interfaces including medium access control and physical layer. The key development in physical layer includes orthogonal frequency division multiplexing, in which multiple access is achieved by assigning a subset of subcarrier to each individual user. This resembles code division multiple access spread spectrum in that it can provide better quality of services for each user. User achieve different data rate by assigning different code spreading factor or different number of spreading code. In an OFDM system, the data is divided into multiple parallel substream at a reduced data rate and each is modulated and transmitted on a separate orthogonal subcarrier. This increases symbol duration and improves system robustness. OFDM is achieved by providing multiplexing on users' data stream on both uplink and downlink transmission. This is the basically network management system in WiMAX technology, in which we have shown the two layers, physical layer and MAC layer. Physical layer provide the interface between different user and the system. It allows various use of directional antennas, two type of duplexing supported by physical layer, frequency division duplexing and time division duplexing. It also supports full and half duplex stations and it has adaptive data burst profile. Different transmission parameter like modulation and forward error correction can be modified on a frame by frame basis for each subscriber station and profiles are identified by interval usage code. Here is the example of time division duplexing. It uses different time slot for downlink and uplink subframes and according to requirement we can vary the downlink number of downlink and uplink subframes according to the requirement. Media access control layer, it is basically connection oriented and channel access is decided by basically base station. It has two type of access, uplink map and downlink map. So in uplink map, basically it defines uplink channel access and uplink data burst profile, what are the modulation and what kind of error correction coding we are going to use in uplink channel access. It all things are defined by uplink map, where in downlink map we are defining the different kind of power profile and error correction and detection coding scheme which are used in downlink connections. It is the example of time division duplexing downlink subframe. In time division duplexing downlink subframe, the DIUC basically stand for downlink interval usage code. It specifies the modulation and coding scheme and other transmission for downlink data burst. Similarly, to avoid different interference, we uses transmission and reception transition gap, which and preamble is used to identify the subframe from which user and from which base station the packet is transmitted. Here is the block diagram of uplink subframe. In uplink subframe, the uplink interval specify the modulation and coding scheme and other parameter for uplink burst. It has three main part: access burst, collision and access burst, and it contains initial maintenance opportunities, request contention opportunities. Uplink, when we talk about uplink frames, in initial maintenance opportunities, it is determined to network delay and request power or profile changes. In this, collision may occur in this interval. Second was request opportunities, in which the subscriber station request for a bandwidth in response to polling from base station. All in this interval, collision may also occur. And third was the data grant period. In this, the subscriber station transmit data burst in the interval granted by the base station. Now, the subscriber station may request bandwidth from the base station in three ways. The first one is using contention request opportunities in the interval being polled by the base station. Subscriber station may send a stand-alone MAC message called bandwidth request in an already granted slot and piggyback a bandwidth request message on a data packet. So, in this manner, the subscriber station may request for a bandwidth, and in response to bandwidth allocation, the base station grant bandwidth in one of two modes: grant per subscriber station and grant per connections. These decisions are based on the requested bandwidth, and the quality of services required by the subscriber station. Grants are notified through the uplink map. Here is the example of bandwidth request grant protocol. In first step, the base station allocates bandwidth to subscriber station for transmitting bandwidth request. In 2.1, the subscriber station transmit bandwidth request, and in 2.2, the subscriber station 2 transmit bandwidth request. Base station allocates bandwidth to subscriber station for transmitting data based on their bandwidth request. Bandwidth is also allocated for requesting more bandwidth. In 5.1, subscriber station 1 transmit data and bandwidth request, and in 5.2, subscriber station transmit data as well as bandwidth request. Now, these bandwidth requests are scheduled, are also supported some kind of scheduled services, which are unsolicited grant services, which are real time, periodic, and it has fixed packet size. It is used in voice over internet protocol, and in unsolicited grant services there is no periodic bandwidth requests are required. In real time polling services, it is also real, periodic, but the data size is variable. Base station basically issues periodic unicast poll. Non-real time polling services, which in this we have variable size packet with loose delay requirement. Base station issues unicast poll regularly, and it can also use contention request and piggybacking. Best effort services, in this services, base station never polled individually, and it can uses contention request and piggybacking. So thank you. These are the two references which I have used while preparing these PPT.